It's the same thing. So all of these, if you would, in the middle, all of that in the middle, you have copper wires. You know what I'm talking about. And then this is plastic outside of it. What is the purpose of plastic? Insulation. Thank you. You can read my mind. Same thing here. So these are connective tissue outside of a nerve bundle. Nerve, your neurons. This is a neuron. This is a neuron. Of course, axon, 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 cross section of an axon. If I cut up right here, this is an axon. I cut it like this. What do you guys see? Right? You see a circle, right? That's what axon is. That's what you see. They cut that nerve bundle, that cable, they cut it like this, and that's what you're seeing. And outside of it, of course, is a Schwann cell, which I will get into it here in a minute. Hang on. Okay, so you have, here is a nerve bundle. That's what I want you to know. Surrounded by connective tissue for insulation purposes. And then inside of it, you have another cable. They're throwing the term fascicles. I'm not too crazy about that term. But that's what they are. This is a fascicle and surrounded by connective tissue. And inside of it, you have many, many neurons. Some less, some more, some equal amounts, some 2 or 3, some, I don't know, 50, 20. Then the next question on your questions at the beginning, you remember that I asked, what is the difference between myelinated neuron and unmyelinated neuron? Am I making some sense, everybody? So, this is the unmyelinated neuron. On in front of a word in English language means without. Right? Do I make sense? So, unmyelinated neuron is a neuron that does not have myelin. So what is myelin? I will show it to you in a minute. Think of a pizza dough. It's big, right? A pizza dough. And wrap it around your arm, right? You know what I'm talking about? Am I making some sense? Wrap it around you. Your arm is axon. The pizza dough is Schwann cell. And that Schwann cell goes around your arm how many times? 4 or 5 times. Right here. That is myelinated neuron. You all know what pita bread is. Huh? Do you eat pita bread? Pita bread. Not my arm. If pita bread on my arm might go 2 or 3 times. But can I borrow your arm? And on his arm, how many times it goes? Pita bread. Once. So that would be, still have Schwann cells. Right? Do I make sense? You still have Schwann cells, but that Schwann cells does not go around, like, thank you, like pizza. Am I making some sense, guys? I'm just making an analogy. I'm comparing apples with oranges. I'm comparing Schwann cells with pizza dough and pita bread and your arm. I hope I'm making some sense. Okay. So right here is the axon. You have the Schwann cell. What was Schwann? Amir, what is Schwann? What's the name of the scientist who first discovered this? You discover something, you call it after yourself. You don't like your name, call it after Amir. So I'm going to call this cell Amir cell. You discover it, call it after yourself. That was his name. So here are unmyelinated neuron, which there is Schwann cells, but it doesn't go around 2 or 3 times. Here they are. You have the Schwann cells that goes around 2 or 3 times, and of course you have the axon. Right here in the model. Are you guys with me? You have the axon with mitochondria in there. Look at this, 3, 4, 5 times. If you look at it in the lab, and this is one Schwann cell, this is another Schwann cell, and there's another one here. You guys want to know, and I will go over it. Why is this? Why do you have Schwann cells, Schwann cells, Schwann cells? Why not one Schwann cells for all? We'll go over that. Hang on. Okay, so and in between the Schwann cells is called node of Ranvier. It's not here. Next slide. Okay, this is node of Ranvier. This is node of Ranvier. Why is that? Hold on to your pants. You heard of that expression?
Yeah.
I think it's a nasty expression. What does that mean? When are people making up that slang expression? What are they thinking about? They have dirty mind, I think. I don't know. Okay, here is a cross-section of nerve bundle on your slides in the lab. This is a nerve bundle. This is a nerve bundle. Connective tissue, axon. This is an artery. These are all fat cells, if you would. nerve bundle, high magnification, connective tissue, axon. What is the name of the cell? Neuron. Of course, if I ask you, I cover all of this. Well, I cannot do that. But if I show you, put a piece of tape here for lab practical, what is the name of the cell? It's a neuron. And then if I move the tape and put it here, what is the name of the cell? Schwann cell. So right here on this, you are seeing cross-section of axon. And of course, all of this white area is a fat myelin. Myelin sheet is made up of fat, phospholipid in bio 1. And quickly, let's visit bio 1. What is cell membrane made up of? Phospholipid. So, all of this from here, you guys see that? All the way to here is phospholipid. Have been around several times. The pizza dough, still made up of flour, wheat flour. You all know what I'm talking about? It's not meat in there. And pizza dough. Pita bread, same thing. Flour, same thing here. Okay, I hope I'm making sense. Okay, here it is. They're showing you that what happens, the difference between myelinated and unmyelinated neuron. And you have a Schwann cell, which is not myelinated. It's all cytoplasm. This is phospholipid. But look at here. The blue is cytoplasm. Do you guys see what I'm talking about? This is a cytoplasm from here to here, but this is all phospholipid. And this is the nucleus of the Schwann cell, or nucleus of the Schwann cell. Right here. Let's move on. Okay, the next thing, if you would, on your, so I have answered you guys, what is the difference between myelin and myelinated neuron? That could be a nice essay question. Write down the differences. And then I asked you neuromuscular junction. I did not go over that, so let's go over that quickly. If you would, we do have a slide in the lab which goes over neuromuscular junction. Here is a neuron, and here is the muscle. So these are axon knobs or axon terminals, and when they are not physically attached to each other, they are not physically attached to each other. There is a little gap between them. That's what they call it, junction. Very little gap. So the gap between axon terminal and muscle, it is called neuromuscular junction. Am I, oh no, which one? Oh, yes? Easy?
Yes.
I hope I'm making some sense. That's what this, you do have slide of this in the lab. You do have slide. Okay, let's go. So I did answer that question, and then what else? Action potential. We are moving to action potential. Let's go. There's nothing hanky, action potential, what happens between presynaptic neuron and postsynaptic neuron. We might be able to cover that today too. I doubt it. We'll see. Let's try. Right here. Okay, so it is important that you guys know the difference between outside of the cell. This is axon. Let me bring it to the ballpark. This is the axon, right? And this is the cytoplasm of the axon. This is outside of the axon. This is inside of the axon. Am I making some sense? And they showed it. They cut off a piece, a bit. They cut off a bit of that in the cell body. All I'm going to talk about is neuromuscular, the action potential. I'm going to talk about what happens in an axon. Am I, yes? Good. If I'm not hollering, stop. So what happens, you guys, when a neuron is at rest? They call it resting potential. See, the stuff that I can spell, I write on the board. The stuff I cannot spell, I say, look it up, right? Resting is called resting potential. Okay, resting potential when a neuron is not stimulated. Stimulated, right now, that was stimulation. The light is stimulation. If somebody brings a bottle of perfume, that is stimulation. Is that right? Your eyes can see, that's stimulation. Does that make sense? Your taste buds are stimulated when you eat something. I hope I'm making some sense. You're being touched, right? They can feel it. That's what you're talking about. But But before I touch them, is that right? Their neuron is on resting potential. So let's talk about resting potential before I talk about action potential. Let's talk about that. What is resting potential? Resting potential outside of the neuron is full of sodium. Na. Inside of neuron is full of potassium, but not as nearly. Inside of neuron has a lot of ATP and protein molecules, and those are the main ones that make inside of neuron negatively charged. And outside of neuron, since you have a lot of sodium, make outside of neuron positively charged. Why positively charged? Because sodium is positively charged. Do I make sense? Are you with me or not? Okay, so if I put an electrode, do we have, oh, come on, give me a break. Yeah, just come out, no, 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 no. Sorry, okay, I had a picture. I don't have it anymore. I had a picture. So if I put for example, an electrode outside, right? And I put another electrode inside. You all know what I'm talking about. And attach, look at my hand right here, not my fingers. My hand is a voltmeter. They have done it, they're still doing it in laboratories all over. So when I attach it, one to the outside, one to the inside, electrodes, and attach it to the voltmeter, okay? Then the voltmeter is going to read minus 70 millivolt. The cell is at rest. I have not touched them. Are you with me so far? Okay, so the cell is at rest when you put one electrode outside, one electrode inside, and the voltmeter here, the face of voltmeter has the gadget, that the gadget reads minus 60 millivolt. That means inside is have a lot of negatively charged, minus 70 millivolt. And then scientists came and stimulated that neuron. They poked it. Oh, am I with me? Are you with me? When they poked the neuron, what happened? A lot of sodium went in, and inside of the neuron became positively charged, and the voltmeter is showing what? Positive 40 millivolt. Millivolt is very, very small. Most of you take physics. Very small amount. Very, very small amount. But they were able to measure that. We can measure milliseconds, right? Yeah, Olympics. You guys run 100 meter, 200 meter? Does any of you're supposed to do that? Don't you do that? Okay, I'm not even talk to coach. I ran 100 meter, 200 meter. Of course, I didn't play soccer. I ran 100 meters. But anyway, okay, so right here, that's plus 40. Those electrodes, you remember? Do you remember? The voltmeter, one outside, one inside, and this is the voltmeter. It was minus 70 millivolt. I poked the neuron with a tweezer, with something, with a needle, and the voltmeter went phew, to 40. Am I yes or am I not? Yes? Yes. Good. Okay. So that is action potential. A lot of sodium went in, made inside of the axon positively charged. And what happens, sodium ion more inside of the algae, I didn't talk about potassium. Potential is all or none. Oh, another thing, what it's in here, Brandon wrote it down. What he says is all or none. So have you had a fly to move around your mouth? We can catch it. You feel it. I mean, not catch it, not catch it. You can feel it, right? But a fly move around bottom of your foot, on the heel of your foot, you don't even know it exists. Am I making some sense? That's what it is. All of the neuron, in order for you to feel, in order for him to feel that I touch him, I poke him, all of the axon must go through action potential. If a segment of it doesn't go through, then it's not action potential. So it's all or none. I hope I'm making some sense. All of the action potential must go through. Eventually, a neuron cannot stay in the state of action potential. A neuron must come back to resting potential. It must. It will. If it doesn't, Houston, we got a problem. Have you watched Apollo 13, the movie Apollo 13? Is it Houston? Tom Hanks? Say Houston, we got a problem. When I do these things and put on YouTube, do I have to get permission from Tom Hanks and Apollo 13? It's becoming a crazy world we're living in. Anything you say, anything you do, can I have your permission, please? It's nuts. But anyway. Okay, so let's go. Right here, action potential is moving down the axon. And then the next question is for Thursday. What happens between presynaptic neuron and postsynaptic neuron? We pick up on action potential on Thursday. Is there any question before I lose you all? We try